This is a model answer for question 2 of the core Resit paper of Key Assessment 3. And we are looking at the mass of product formed over time in an enzyme reaction. Calculate the rate of reaction in the first 10 minutes at 30. So we need to first of all go, which curve are we talking about? 30 degrees. It's this curve, and first 10 minutes we're looking at this area here. The rate is what happens per unit time. So it's our change divided by our time. What's the change? Well, the change is up from, it starts off at 0 there and it ends up at that point there, and push that line across. What's the value? Well, that one will be 3, so that's 2.6. So our change is 2.6 milligrams per dm cubed divided by the time. So that's gone up to 2.6 and that's gone up to 10. So our time is 10. So 2.6 divided by 10, you can do that in your head, is 0.26. And we're just going to put that in there, 0.26. For 1 mark. The initial rate of reaction was slower at 30 than 50. So this line here, that's slower than this steeper line for 50 there. So our graph 50. So let's just, there we go. Why? This is just simple temperature, a lower temperature. What do we know about enzymes at a lower temperature? Well, pretty straightforward. Low kinetic energy. And there's 2 marks here. So low kinetic energy, what effect does that have on the enzyme and the substrate? There's going to be fewer collisions, or alternatively we could say fewer enzyme substrate complexes formed. So just the normal theory there. Explain the shape of the curve between 20 and 60 minutes at 50. Let's get the right curve. 50 and between 20 and 60 minutes. So we're talking about this bit of the curve there. And so if we were describing that, we'd say the line levels off, it plateaus. And what we notice is actually it's below the 30 curve. So something's happened to stop that product being formed. And again, it's just back to your theory again. Well, at higher temperature you're going to get denaturing of the enzyme and so on. And we just need to explain that for as many marks as we've got. So 3 marks there. So let's say the word, the enzyme denatures. And we could put that in alternative words. We could say alters to 3D structure or tertiary structure. So 3D tertiary structure is changed. That's what that means. We've got 3 marks. So we're looking for the three main points here. What causes that? What is about the higher temperature? Well, we need to say, breaking of hydrogen bonds. And why doesn't this enzyme work anymore? what's this change? Well, why are we interested in this change in shape? Well, that's because we've changed the shape of the active site. So, change in the shape of the active site. We'll always try and mention active site somewhere in enzyme questions. That would be enough to get you them out, but I would always add this next bit as well. The substrate cannot bind to the active site, or it's no longer a complementary fit. Next up we have got ethanol dehydrogenase. That's an enzyme, and it's in the liver, and that's our ethanol to ethanol. So that's our substrate there. This is an inhibitor. Okay, and we've got those diagrams there. Use the information in the diagram to explain how methanol inhibits ethanol dehydrogenase. Well, as soon as you see inhibitor, I'm thinking about competitive inhibitors and non-competitive inhibitors. To figure out which one of those it's going to be. Well, if we look at these, we see this group here is the same as this here. So that's probably what we're looking at. The other bits are pretty similar as well. So it's a similar shape. So that would lead me to go down the route of it's a competitive inhibitor and then give 3 marks worth of stuff there. So I'm going to put shape of methanol is similar to the ethanol substrate, or it's a similar chemical group or something like that. And then just to explain how competitive inhibitors work. So methanol attaches to the active site. It blocks the active site, prevents entry of the substrate, which is ethanol. No enzyme substrate complex is formed. That sort of story. And this is competitive inhibition. And where the marks are actually is one for that, one for that, and one for that. But that's the information I'd always try and give, and I've still got a couple of spaces there. 9 marks.